Okay, in this lesson 5.2 on counting, I'm going to utilize some of the ideas from the previous lesson dealing with sets. But let me first go over the first theorem that we're going to apply. This is called the multiplication principle of counting. And it states if a task consists of a sequence of n choices in which there are x sub 1 selections for the first choice, x sub 2 selections for the second choice, and so on. And finally, for the last choice, or the x sub n choice, there's x sub n selections. Then the task of making these selections can be done in this many ways. So in other words, you multiply the number of ways. X sub 1 times x sub 2 times x sub 3 times x sub n. So as an example, before I go to the main problems, let's suppose you have 5 students or 5 persons and you want to seat them in 5 desks and you want to know how many arrangements you're going to have. So you have 5 slots. So for the first desk or slot, you can select any one of the 5. So that would be 5. So it'd be 5 choices for that one. But once you've made that selection, then there's only 4 persons left to fill the next one. So you can select any one of the 4. So it'd be 4. And then after that, you've only got 3 left, so you got 3 selections for the next one. And then finally, the next one you got 2. And then finally, you just have 1. So according to this principle, you can find the number of different ways this can be done by just multiplying these out. So 5 times 4 times 3 times 2 times 1 is 120. So 120 different arrangements of those persons. As another example, let's suppose you want to know how many license plates for a car can be done if there's 2 letters followed by 3 numbers. Okay, so 2 letters followed by 3 numbers. So there's 26 letters in the alphabet. So for the first one, I can select any one of 26. And then for the next one, unless they tell me that letters can't be repeated, I can select any one of 26 again. And then for the numbers, there's 10 numbers in the numeric alphabet. So this will be 10 choices here. And again, unless they tell me they can't be repeated, this will be also 10. This would be 10. And then you would just multiply these out. And using your calculator, you should get 676,000. $676. Now, if they tell you how many license plates are possible if the letters and the numbers cannot be repeated, then in this case, you would set it up this way. 26 choices for the first one. And since I can't repeat letters, I can only select any of the remaining 25. And then for the numbers, again, any one of the 10. But since I can't repeat, then for the next one I only have 9. And for the next one then I would have 8. So 26 times 25 times 10 times 9 times 8. And that's going to give you 600. Or I should say 468. Thousand. Okay, so that's one application of the theorem. Let's go ahead and erase this. Okay, I did some examples like the next one, but here it is again. It says write down all the subsets of the set consisting of 1, 2, 3, 4. Okay, so remember we said that the set itself is always a subset of itself. The empty set is always a subset of itself. So basically, you're looking for all the different combinations of the four things taken four at a time. Okay, so the only way you can take the four things of the four is one time. Okay, because you take 1, 2, 3, 4. Doesn't matter what order you put them in. It counts as the same set. So if I put 1, 2, 3, 4, or 3, 4, 1, 2, it's still the same set as long as it contains the same components. So you're taking any one of the four of the four. There's one way to do that, and then to select 3 of the 4. There's 4 ways to do that. To select any 2 of the 4, there's 6 ways to do that. And of course, you have the empty set. 1 way to select, or 4 ways to select one at a time. So it's the set consisting of 1, 2, 3, 4. So these are all the combinations. So the empty set is always included, and then you take each of the elements and form a set. So you're taking one at a time, 1, 2, 3, 4, and then the next set is the next group of sets are the sets consisting of 2 of the 4 elements, and the next is consisting of 3 of the 4, and of course the last one is the set itself. And remember, I said that if a set has n elements in the last lesson, if a set has n elements, then it has 2 to the n different subsets. So in this case, it has 4. 2 to the 4 is 16. So if you count these, you'll get 16. Okay, go to the next one. Okay, went over the formula for this in the last lesson. It says if the cardinality of A union B, remember n of A union B, and the n here means the cardinality or the number of elements or components of that set. So the number of components in the union of A and B is 30. The number of components or elements in the intersection is 18. The number of components in set B is 22. And we want to find the number of components in set A. So here's your formula. N of A union B is equal to N of A plus N of B minus the cardinality of the intersection. So I drew a Venn diagram illustrating this formula in the last video. Here I'm just going to apply it. Okay, so just plug in what we know. We know that N of A union B is 30. N of A is unknown, so here you have it. N of B is 22. And the intersection, the cardinality of the intersection is 18. Plug it in. 22 minus 18 is 4. Subtract from 30, we get N of A is equal to 26. So the cardinality of set A, or the number of components or elements in set A, is 26. Okay, the next one's an application of the theorem over here, multiplication principle of counting, which I did 2 examples already. A man has 10 shirts and 3 ties. How many different shirt and tie arrangements can you wear? Again, using the multiplication principle, it's 10 times 3 or 30 arrangements. Now, also in the previous lesson, I talked about Venn diagrams and mentioned where in some cases they're handy to solve problems involving surveys. Okay, so here's an example of that. Say it's in a recent survey of 100 persons, the following information was gathered. So 59 used shampoo A, 51 used shampoo B, 35 used shampoo C, 24 used shampoos A and B, 19 used shampoos A and C, 13 used shampoos B and C, and 11 use all 3. And the questions that we have here are how many use shampoo B only, how many use shampoo A and B but not C. So one way to solve this particular type of problem, or problems related to this or similar to this, are to draw a Venn diagram. So we have 3 different things, A, B, and C. So those are the 3 different items, so that could be represented by 3 sets. Okay. So this could be, in this case, A and B and C represent different types of shampoo. This could be just items, it could be computers, it could be courses, okay? But here's a way you want to do it. You always want to start with, in this case the last one, or the intersection, because we have several regions we have to fill in here. Okay, so we don't want to start with 59 use shampoo A, because what that means is that the total in circle A is 59. But see, there's some that go in this region here, which will be common to A and B only, or some will be in here, in this region right here, common to just A and C. This region right here where they all intersect is common to all. So you want to start in the middle, okay, or the intersection of the three circles. Sometimes you'll have two items only, so you'll have two circles, and you draw them so they intersect. In this case, I have three. Okay, so I start here where the circles meet. So this tells me 11 use all three. So I would put 11 right here. 11 use all three. And then I go to the next item. It says 13 use shampoos B and C. Okay, so let's look at this region right here. This region right here. Okay, so right, this region we're looking at B and C. So right here, this region right here is B and C. And the total there should be 13. So that means 11 added to this region right here has to be 13. Okay, so this should be 2. That should be 2. Now I have a total of 13 for that one. Okay, now let's go to the next one. 19 use shampoos A and C. Okay, so A and C, so that would be this region right here. This total right here, for these two regions where I have 11 and the one in the region on the left, that total should be 19. Since I already have 11, I need 8 more to make 19. So this should be 8 right there. Okay, and then we go to the next one. 24 use shampoos A and B. Okay, so A and B would be this region right here. Okay, where I have 11 and the region right above that. Okay, so that should be 24, a total of 24. So since I already have 11 there, I need 13 to make 24. So this will be 13. Okay, so I have that. Okay, now since I have all these regions filled out, then I can go to the other one. So now I can go to the top. Doesn't matter which one I do now. So if I go over here and say, okay, 59 use shampoos, 59 use shampoo A. Okay, so that means the total of these 4 regions here making up circle A, right here, these 3 here, that total should be 59. Okay, so you add up the 8, the 11, and the 13, and subtract from 59, and that should be 27 right here. Okay, so that total should add up to 59. Okay, then for the next one, 51 use shampoo B. Okay, so shampoo B. So here I have 4 regions again. In this region I have 13, this one I have 11, this one I have 2, so I need a number over here outside those 3 regions, and the total has to be 51. Okay, so we add up the 13, the 11, and the 2 and subtract from 51, and we get 25. Okay. Now, the next one says 35 use shampoo C. Okay, so let's go to circle C. I already have 3 regions filled out, and the total in those regions should be 35. So add the 8, the 11, and the 2. That's 21. Subtract it from 35. That's going to give me 14. Okay. Now remember that there was 100 people surveyed. So if all these numbers from all these regions here add up to 100, then there's nothing that goes outside the circles. But let's say all these numbers added to 98 only, and we know from the data that there's 100. That means that 2 persons use neither A, B, nor C, and that value would go out here outside the circles. But in this case, these add up to 100, so we're okay. So now we go to the question A, how many use shampoo B only? Okay, shampoo B only. So that means we don't want anything that intersects A or C. That would be this number right here, so this would be 25. Okay, for the next one, how many use shampoo A and B, but not C. A and B, but not C. So we don't include this portion right here. So it's just this portion right here that's common to A and B, but not to C. That's 13. Okay. And that's your solution. 25 for A and 13 for B. So we'll continue with another lesson in this chapter here. So if you have any questions or suggestions, again, as usual, please post them. And if these are helping you, I'd appreciate it if you subscribe to the channel, and we'll see you in the next video.